already seen 22, but I'm just getting back up here. After we go through all the answers, any questions we want to see done by hand or in Desmos, we'll do those. So 22 was C. 23, you have to translate the given expression into some equation or function, and then use that function or equation to find points using Desmos or your calculator. And any of these 3 points you could have used as long as it fell on a whole number, integer, not on a fraction or decimal. And then 24 was D. 25 was also D. 26, you needed to plot 2 points. Didn't matter which two. You should not have a line graph because that's not what it asks you to do. Because it's direct gradation, I would say start at the origin. That would be your easiest point, and then just find another one. So any of those 2 points would work. And then 27 and 28 were both D's. Do we have any questions we want to see, do go over, see in Desmos, go over by hand? So, have another SOL packet to use to practice, to study, refer back to before your SOL on Wednesday. The Desmos Hacks SOL review on your desk, we're going to go through that today. This is really like one of your last chances to ask questions. How do I do this in Desmos? How do I do this in general? Maybe I don't remember doing this. Or can we go through this because it's been a while? You guys are going to find whatever questions you want to go through in that entire packet. We can go in order, we can go out of order, it doesn't matter. And we're just going to go through any questions you guys have. So start looking through that packet, find any questions you have, and we'll start going through those. When you find a question, tell me the section, so they're labeled by objective, so like A, whatever, tell me the number / letters that go with it, and then the number that you want to do from that section. With everything, everyone should be looking through the packet to find questions they may want to see you go over and review. Would you make it 3 on page 2? What's the topic?
Loss section.
So A2A.
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 3.
I'm just writing each one down so that we don't have any repeats. Also, if you did not grab an iPad, go do that because everyone will be trying these Desmos Hacks. A2A, number 3, laws of exponents. Your laws of exponents are listed your Desmos Hacks works really well if it's multiple choice. If it's not multiple choice, you would have to type in your original, use your law of exponents, and then put your final answer in. So I'm going to show you the Desmos Hacks, and then if you want to see it by hand, we'll do that. So for number 3, I'm going to type in the original. So go ahead and start doing that into Desmos. And once you have your original in there and have the whole thing, you're going to add in all the sliders and just change the values to something. I would leave them positive so you don't have to worry about negative bases or anything like that. And just change them to 3 different numbers. And then you're going to start to put in your answer choices, and it becomes a matching game. Which one matches which decimal matches? So it's not A, the decimals don't match. We switch. It's not B. Again, the decimals don't match. A squared, no B. C squared, 2. Not C, so then by default it would need to be D. And those do match. So if it's multiple choice, put all of them in and see which one matches. If it's not multiple choice, then you have to type in the correct answer. You have to use your law of exponents. And then you can type your original problem in, type in your final answer, and see if the decimals match. Anyone want to see that one done by hand? Yes. So using your exponent rules, we are dividing like bases, so we can subtract our exponents. We can actually divide the -6 and 21. 3 goes into both of them, so I divide them both by 3. We have -2/7. So that gets rid of A and C. We know it would be B or D. And then start subtracting your exponents. 7 minus 5. 2 minus 2. I'm just going to write this for now and then simplify it. And 3 minus, remember, if you don't see anything, it's 1. So then b to the 0 would become 1. That would go away. And then all of your variables would be in the numerator, which will give you questions on that one.
A3, number 3.
A3, 11.
A3, 80.
A3, 80. You said number
2, yeah. And then number 4.
Okay. We'll do 3 and 4 on that page. hack works the same on this one. I'm just doing this on my computer because it's easier to type in than doing it at the board. Except E, you have to use a capital letter. Because E is a number. So use capital E instead.
How do we know which one's a number?
So you could test it. Just put in random letters and see if something pops up or not. R is something, I don't recall what it is. I is a number, but it won't show up. But if you just type in something, it'll either give you a slider of some sort. So it would also need to be an expression. You may have to do something with it. 3A. So I'm going to type in the original. You can use the square root inside the keyboard. Or if you forget, you can type in the letters SQRT. The same thing works for the cube root too. So capitalize the E, the rest can be lowercase. You could also capitalize those, it doesn't matter. Add in all your sliders. For your square roots, you have to have positive numbers. If it was a cube root, it wouldn't matter. But if you make it a negative, that was okay. With the odd powers, it'll get undefined, so make sure they're positive. And then we can start typing in answers. But for elimination processes, I'm looking at A and D, and I see the final answers have 12 underneath the square root. I know 12 can be broken down more, because 4 goes into 12, and 4 is a perfect square. So I'm going to skip those two, because those aren't the most simplified, and try B and try C, and see which one of those matches. And if you didn't remember that, you could still try them all. And B is the one that works because the decimals match. Before we do 4, do we want to see that one done by hand?
Yeah.
Okay. So using whatever method you want to do, I'm just going to go perfect squares and pairs. We need to find the highest perfect square that goes into 108. So we would start dividing, or we would check first to see is it a perfect square.
9 and 12.
And it's not. But you said 9 and
12.
9 and 12. I'm going to say there's something higher.
36.
Okay, 36 and 3. So I can break that down to the square root of 36 and the square root of 3. This is a square root, so the index on the outside is 2. I know 2 goes into 6 3 times. 2 goes into 7 3 times, but there would be 1 left over. And then 2 goes into 3 once, and there would be 1 left over. So I have the square root of 36, which would be 6. On the outside, e to the third, f to the third, and that 1g. So I'm looking for something that matches. And I see they both have that. So it's really what's left on the inside. 3, f, and g. Which would make it g. Questions? 4, we're we're going to use the Desmos slider hack again. I'm just going to use you can use CBRT for cube root, or you can go into functions and scroll all the way down and use the nth root. So either or. Add in all your sliders. Because it's a cube root, it doesn't matter if they're positive or negative. You can change it to whatever you want. And then you could start typing in the answers and see which one matches. I can say it's not A. Two, not A, B squared, 2 to the 4th, 10 squared. It's not B. It's not C, and then by default it would have to be D. So D would be your answer for that. Anyone need or want to see that one done by hand? What other questions do we have? Do you want to see one of your go over?
Five.
On the same page.
Mm-hmm.
Alright, so for your radical operations, anytime it's just numbers, you can put that straight into Desmos and see which decimals match. So if I were to type in the square root of 54, make sure you come out of it, plus 2 times the square root of 24, I get some decimal. And then, so again, you could eliminate some of these if you know 78 could be broken down more. I don't remember if that is true or not. But then type in your answer choices and see which one matches, which happened to be A. Other questions? Do you have to break down the 24? If you're doing it by hand, yes. I would say almost all of them can be done by hand, but I would still double check it in Desmos if that's the viable one. looking through the packet, find other questions that you maybe don't remember how to do, want to see, go over, review how you do this in Desmos. Five C and what next? 8.5C, your inequality word problems, and number 15. So you will have access to a highlighter inside the SOL. Be sure that you go through, highlight what's important. I'll do that as we read. Maria drives an ice cream truck. She only has 40 cloves left in the truck. The double scoop sells for $3. And each triple scoop sells for $4. She needs at least $45 in sales to break even, so she won't owe money and won't make more of a profit for breaking even. And then we need to figure out what is a possible combination of double and triple cones she can sell in order to make enough money to break even. So we first need to realize we're talking about two different things, double scoops and triple scoops. We're comparing the two different things. And because of that, we're going to have to use a system of inequalities. We're going to have two of them. I'm just going to use E and T for double and triple. Actually, I'm going to use X and Y. You can use whatever variables. So X I'm saying is the number of double scoops, Y is the number of triple scoops. And then I need to set up my two inequalities. So the money goes together. The 3, the 4, the 45, that's all going to go together. And I have 3x because at the end there's going to be a total I'm adding. 4y. I need at least $45. So that's going to be one of your inequality symbols. Which one? Greater than or equal to. So we want $45. If we get more than that, that's great. But we don't want less than that. So that's one of them. Then we have just one more number left of 40. And it says she has 40 cones left in her truck. What symbol would we use?
Equals.
Less than or equal to. Because we can go past what she has, but we can go up to 40. We could go less than that, we can go up to 40, we just can't go past that. And then, if 40 is the number of cones total, what would we add together?
T plus T.
Say again.
X plus Y.
X plus Y. So then at this point, you have your two inequalities, and you would just graph that into Desmos. We have 3x plus 4y is greater than or equal to 45, and x plus y is less than or equal to 40. We're going to find where those two overlap, and the question is looking for what is a possible combination of double and triple cones she can sell. There are multiple. There are many. Give me one. she could sell 20 double scoops and 10 triple scoops. Give me one more.
25 double scoops and 11 triple scoops.
So 25 and
11.
25 and 11. Okay. Because that would be still in here. 25 and 11 would be about right there. So as long as it fell in the overlapping shaded area and didn't go over 40, because this is everything, not just between 40 up to 40. So once you get to 40, you have to stop. So really here and here is really the section you need. Everything outside of that you couldn't do. What other questions do we have?
You have to like graph the linear inequality, but the sides are like different. Like how do you know where to shape it?
You're online. No.
Oh, like the last one I equal to, how do you know how to shape it?
Oh, okay. So this is general.
I mean like when there's two equations and you have to find the
And you have to find.
you have to find like which part you shade. Like
Got it. Okay. So go back and do whatever. So in, let's say I had this, I solved it, whatever. I know it's going to be a solid line, and it's greater than or equal to, so I have to shade above that. Okay. And then I put in my other one, or I get my other one, I solve it, and this would be y is less than or equal to negative x. Okay. It's less than or equal to, so it's again going to be a solid line. I'm shading below that. So this first one I already shaded above. The second one I'm shading below that. And they should overlap. You're looking for where do they overlap. So if you just had to draw one section, it would, or just shade in one section, it would just be where they overlap. Now, you'll have a highlighter, and you can change a different color. So if you want to do both and see where they overlap, you could do that. Other questions? Make sure you have gone through every single page to make sure you do not have questions. Have you gone through every single page to make sure you don't have questions? Do that.
Can we do A9?
This one,
A9.
number one. Okay, A9, number one. Is your line of best fit, curve of best fit. So you're given your regression curve of best fit to put into Desmos on the paper, but when you go to take your SOL, you won't be given that, so you have to know that. I would say if you don't remember off the top of your head, think of your equation of a line, think of the quadratic equation. So y equals mx plus b, y equals ax squared plus bx plus c change all the x's and y's to x1, y1, change your equals to the total. In number 1, anytime you see years, so we're not dealing with exponential progression in this, just linear and quadratic. But anytime you see years, you're doing line of best fit. Also, this one says line of best fit, so you know you're using the first one. Change the first year to 0. Every year after that, count how many years has it been since the first year. So 1980 to 1990 would be how many years? And 1980 to 2000, 20. 80 to 2010, 30, and 80. No. Sometimes the pattern is the same, sometimes it's different, so make sure you double check that, don't just assume. Then in Desmos, we're going to put those in to a table. Once you put in a couple, it will start to recognize the pattern, so you just keep hitting enter. That was one to this. And then put in your y values. Oh, mine must have cut off. Where was it? Okay. Oh yeah, I just tried. Okay. All right. So we see it's making a line, and then we're going to type in our y1 tilde mx1 plus e. And that will give us our our line of best fit. If it should say how many decimal places to round to, so be careful and make sure you're paying attention to that. And this one, we're just going to put all the decimals. So y equals 0.22x plus 4.79. And then based on the equation for the line of best fit, predict the cost of pizza in 2025. So first, how many years has it been from 1980 to 2025? 45. So now that we know that number in Desmos, we're going to put x equals 45. And find where those two lines cross. And it says round to the nearest hundredth. Well, there's nothing to really help us round that to, so just 14.6. Questions on that? Other questions?
Do you have to simplify the years?
You can do it as is, but your equation is going to be different. And then you wouldn't calculate how many years this has been. I would say it's easier just to change the years first. Other questions? Desmos to help you find these, but if you don't know what you're looking for, Desmos will only help you so much. So at number 1, you're determining, is this direct or inverse or neither? So based on the equations, you could find that, but you won't be given that on the SOL, so you have to remember what the equations look like. If you remember what the graphs look like, you could type, you want to do all of number 1, everyone, A through E.
You just do feel.
So if you remember what the graphs look like, then you could compare those. So I could type in the first one and see what that does. And that looks like a line that goes through the origin. So that would be direct. So either based on the equation or based on the graph, you have to know whether it's direct, inverse, or neither.
Can you do one and number 2?
Sure. Gabrielle, take a couple others from number 1 and we'll do number 2. E. So if I'm basing that off the equations, y equals x over 3. For direct, it's y equals kx. And I could rewrite this as y equals 1/3 x. Or you could check the graph. I could put it in exactly as is. And again, we have a line that goes through the origin. So that one was also direct. Catherine, which one's in 2?
A and B.
So for these, you can either use the rule, try to find k, and see if it's the same. You can put them into Desmos and see what the graphs look like. So I'll put this one into Desmos first. By adding in the table and putting those 6 numbers in. And it looks like it might be a line, but it doesn't go through the origin, so I'm thinking maybe neither, or it's slightly making a curve, so it could be inverse. So then I have to check the k values. So I don't think it's direct, so I'm not going to divide, but I'm going to multiply them to see if they're the same. -6 times 8, -4 times 12. And -3 times 16. And if you get the same thing for each, you know it's inverse, so multiplying, inverse, dividing, direct. So that first one would be inverse. Now, just looking at B, the table, they're way too far apart to even really get a good grip on. Is it going to be inverse direct? This is shape what I'm talking about. So when I look at these points, it looks like they're making a line, but they're really far away from the origin, so I have to really play around with that and count the slope and figure out is that direct or not. Or I could just divide them. And if each one is the same, then I know that's right. So 84 over 12, 119 over 17, and 140 over 20. And they are the same, so that would be direct. And then if you get a case where it's not the same for either, then it's neither. Other questions? Period wanted to go through, so if you're looking for something specifically, I can tell you where it is. Fifth period wanted to look through some of the linear transformations, the steepness, the shifting. If you want to go through those, I can tell you where to find it. Not a big two phases. I'm assuming you're good with everything.
System of inequalities number 19.
That's 85.
Yeah, 8,
8, and what was the number?
17.
85E, number 17. So anything, inequalities or equations related, Desmos will be involved. You may have to set something up first. So like with the inequality word problems, you have to set them up first. But this, you can put these directly into Desmos. You don't have to solve them. You can if you want, or if you solve them, I would put them back in and double check to make sure that they match. Anything with equations and inequalities, you should have lowercase letters. So we're going to draw in the two lines and then just draw in the overlapping. So you could draw each one in individually. So that part's really up to you. And then looking at Desmos, let's say for this first one, I see that the y-intercept starts at -2, and if I try to find another point, it looks like it goes through this. So my slope would be up 1 to the right 3, and I could check that. If you want to go off your graph, you can do that. And then it would be the same thing the other way. Down 1, left 3, as many places as possible. These should both be solid lines. This one, I have it already, but you could also refer back to Desmos just to make sure you're graphing it right. Should start at 1, have a slope of -1. And then the overlapping section based on Desmos is, so if I were to make this into 4, it would be the top right-ish. So it should be this one. If I wanted to graph that or do that from each individual, I can say this one is going to be shaded above this one. And then the other one is going to be shaded above that one as well. And where those two would meet would be this section. Anyone have a question in mind right now? We're going to do some more of these on Wednesday because most of you, if not all of you, should be taking the test in the afternoon. So I would say go through, find some that you want to see you go over for Wednesday. But then for the remainder of class, you can keep working in this packet, work on JLabs, work on your 8-ball packet. Remember that those are due on Friday, your JLabs and your 8-ball packet. You can work on those math, missing, all missing. Come see